if you want to take a vacation, take it before that date, because who knows what will happen.
At this exact moment, something extraordinary is happening behind our star. The interstellar object Atlas, only the third visitor from beyond our solar system ever detected, is in solar conjunction, completely hidden from our telescopes. 5 days ago, on October 21st, it positioned itself on the exact opposite side of our star relative to Earth, becoming invisible to our entire observation network. In exactly 3 days, on October 29th, it reaches perihelion, the closest point to our star in its trajectory. At this moment, 33 gigawatts of solar radiation will bombard its surface. To put this in perspective, it's 1/3 of the total energy production of all United States nuclear reactors combined, concentrated on a single object at 135 astronomical units from our star. This is the most energetic moment of its million-year journey through interstellar space. And here's what makes this fascinating. If any unusual physical process were to occur, whether massive ice sublimation, activation of complex chemical processes, or something more extraordinary, it would be exactly now when we cannot observe. The timing raises profound questions. Why is this specific object, with all its already documented anomalies, passing through the point of maximum solar energy during the only window when we are completely blind? Is it a statistical coincidence, or is there something more fundamental at play? Avi Loeb, Harvard professor and former chairman of the astronomy department, published a warning that echoes ever louder. If you want to take a vacation, take it before October 29th, because who knows what will happen. These words are no longer distant speculation, they're about the next 3 days, about processes that may be occurring at this exact moment. Atlas is systematically breaking established patterns for interstellar objects. Since its discovery, it has accumulated a series of characteristics that individually could be explained, but collectively form an unprecedented scientific puzzle. The first anomaly, impossible orbital alignment. Atlas's trajectory is aligned to just 5 degrees from the ecliptic plane, the disk where all planets orbit. For an object coming from interstellar space, the probability of this happening randomly is only 0.2%. But this isn't just a statistical curiosity. It's the ideal trajectory if you wanted to access multiple planets with minimum energy expenditure. If you were designing a mission to visit Mars, Venus, Earth, and Jupiter in a single pass through the solar system, you would choose exactly this path. The ecliptic alignment maximizes flyby opportunities while minimizing necessary course corrections. The second anomaly, impossible chemistry. Spectroscopic data from the Keck 2 telescope revealed that Atlas is emitting nickel in proportions never seen in natural comets. On Earth, this specific signature only appears in highly controlled industrial processes, specifically in alloy production through the carbonyl process. The nickel is concentrated in a 600 kilometers region of the nucleus, while cyanide, another detected compound, extends for 840 kilometers. If both were naturally sublimating from ice, they should follow similar patterns based on volatility and solar heating. They don't. The nickel acts as if it were part of an organized structure, not random sublimation from a dirty snowball. The third anomaly, revolutionary composition. Analysis reveals that Atlas contains only 4% water by mass. This is revolutionary. Comets are essentially dirty ice deaths. Water should be the dominant component. Borisov, the previous interstellar comet that everyone agrees is natural, had typical aqueous composition. Why is Atlas fundamentally different? More intriguing, the polarization of light reflected by Atlas is extremely negative, a phenomenon never observed in known comets, including Borisov. This suggests unique surface or structural properties. The fourth anomaly, extraordinary mass and scale. Atlas is estimated at 33 billion tons, 1,000 times more massive than Borisov, 1,000,000 times larger than Oumuamua. With a minimum diameter of 5 kilometers, it possesses sufficient mass to carry significant payloads through interstellar space. To put in perspective, this mass would allow transporting thousands of car-sized probes or hundreds of larger structures and still maintain maneuverability with the energy available at perihelion. The fifth anomaly, the mysterious anti-tail. Between July and August, Atlas developed an anti-tail, material ejected toward our star, contrary to normal cometary behavior. Analysis confirmed it's not a perspective illusion. Material was genuinely being ejected against solar radiation pressure, suggesting active internal energetic processes. Loeb created an evaluation scale from 0 to 10 for potentially artificial interstellar objects. Atlas scores 4. Not conclusive, but significant enough to justify serious investigation using planetary defense resources. The reaction of scientific and defense institutions to Atlas has been extraordinary and, in some aspects, alarming. For the first time in history, protocols normally reserved for extinction threats have been activated for an object that cannot directly impact us. Activation of the Planetary Defense Network. The International Asteroid Warning Network, ION, created specifically to detect and track objects threatening civilization, tanifated an intensive 3-month monitoring campaign for Atlas. This is unprecedented. IAWN doesn't waste resources on interesting scientific objects. They exist to prevent extinction events. The campaign began on October 27th, 2 days before perihelion, and will continue until January 2026. This means the decision was made based on pre-perihelion data, suggesting that the already documented anomalies were sufficient to justify treatment as a potential threat. But here's the paradox. Atlas is not on a collision course. Its maximum approach will be 1.8 astronomical units farther than Mars. There's no physical possibility of impact. So why activate planetary defense protocols? NASA's deafening silence. The highest resolution images of Atlas were captured by NASA's Mars Reconnaissance Orbiter on October 3rd, when the object passed 190 million kilometers from Mars. The HiRISE camera has 30 kilometers per pixel resolution at that distance, 3 times better than the best Hubble images. These images remain unreleased. Avi Loeb has publicly requested access, repeatedly mentioning in blog posts and direct emails to NASA. The silence in response is conspicuous, especially considering these are the most detailed photographs of the object in existence. In stark contrast, the European Space Agency has been relatively transparent. The ExoMars Trace Gas Orbiter imaged Atlas and released data showing classic cometary appearance, a diffuse point with small tail. Reassuring until you examine the spectroscopic analysis of the same data, which reveals anomalous chemistry, physical scenarios, and their implications. Physics allows multiple explanations for Atlas's behavior. Each scenario has profound implications for our understanding of interstellar objects and cosmic processes. Scenario 1. Exotic natural comet. Atlas may be a comet with unusual composition formed under radically different conditions from our solar system. Other stellar systems have different metallicities, distinct formation temperatures, chemical processes that don't occur here. The nickel emissions could result from natural carbonyl processes in the nucleus, spontaneous chemical reactions under specific temperature and pressure conditions. The low water concentration suggests formation in a volatile pore region, perhaps near a young, hot star. This scenario explains the chemical anomalies but struggles with orbital alignment and perfect timing. Coincidences happen, but multiple simultaneous coincidences test statistical credibility. Scenario 2. Controlled fragmentation. The object may be disintegrating in a highly organized manner, releasing internal components with distinct physical and chemical properties. This would explain the anomalous emissions and composition variations observed. Fragmentation could be triggered by increasing solar heating as it approaches perihelion. Internal structures, preserved for millions of years in interstellar cold, begin to sublimate or react chemically when exposed to intense solar radiation. Scenario 3. Active orbital maneuver. If some process alters Atlas's velocity during perihelion, we would see measurable orbital changes in the following weeks. A deceleration of just a few km divided by s would be sufficient to keep the object permanently in the solar system. Perihelion offers the ideal energetic window for such maneuvers. It's the moment of maximum orbital velocity, when any applied impulse is amplified by orbital mechanics, to the famous Oberth effect used by all interplanetary missions. Scenario 4. Ejection of smaller component. Atlas may release fragments or smaller components during maximum perihelion heating. With its estimated mass of 33 billion tons, it could eject thousands of smaller objects and still maintain structural integrity. The astronomical community is deeply divided about Atlas, reflecting fundamental tensions about how science should deal with anomalies and uncertainties. Jason Wright, astronomer at Penn State, published one of the most devastating critiques of Loeb's work. In a blog post titled simply, "Avi and Atlas," Wright systematically dismantles each proposed anomaly. On the supposed absence of coma, Wright argues that Loeb misinterpreted how telescope tracking works. When you track a moving comet, you keep the nucleus sharp while the background blurs. Of course, you don't see diffuse coma clearly in this imaging mode. On size calculations, Wright contests that Loeb assumed asteroid albedo, 5% reflectivity, to maximize size estimates. If Atlas is a comet, it would have a smaller nucleus surrounded by bright coma, not the giant mass Loeb calculates. Loeb responds that his critics are so invested in conventional explanations that they reflexively dismiss anomalous evidence. He argues that science has a conservatism problem, paradigm shifts are resisted, outsider ideas are dismissed too quickly. Wright accuses Loeb of bypassing peer review, publishing directly in blogs and interviews before submitting formal papers. Loeb responds that the peer review system is too slow for transient phenomena. Atlas won't wait months for editorial committees to deliberate. Betting markets currently place odds at 75% natural comet, 25% artificial origin. These aren't scientific probabilities, they're aggregated human judgments. But they tell us there's no consensus, it's deep uncertainty unfolding in real time. The coming months will offer 3 distinct opportunities to definitively resolve the Atlas mystery. November 4th, JUICE flyby. The European Space Agency's JUICE probe will make the first post-perihelion observation, passing 64 million kilometers from Atlas. This will be our first opportunity to see how the object changed after exposure to 33 gigawatts of solar radiation. If Atlas executed a maneuver during perihelion, the effects will be obvious in JUICE's data. Velocity changes of just meters per second will be measurable. December 19th, maximum Earth approach Atlas will pass 1.8 astronomical units from Earth. All major ground-based observatories will be directed at the object. The James Webb Space Telescope will be able to detect thermal signatures and molecular composition in extraordinary resolution. March 16th, 2025, Jupiter Encounter Atlas will pass 54 million kilometers from Jupiter, with NASA's Juno probe providing frontline observations. If the object released smaller components during perihelion, some may be on trajectories that bring them near Jupiter at this time. Each window will build upon the previous one. If the object behaves exactly as celestial mechanics predicts, we'll confirm that interstellar comets can have surprisingly diverse properties. If deviations appear, we'll face a new type of phenomenon that defies current categorization. In 3 days, perihelion happens. In 3 weeks, the first post-blackout data begins to arrive. The central question is elegantly simple. Will Atlas's trajectory change? If the object follows pure gravitational laws, we'll confirm that interstellar comets can have surprisingly diverse properties. We'll learn about formation processes in other stellar systems, about how different chemical environments produce objects with unique characteristics. If orbital deviations appear, if non-gravitational accelerations are detected, if multiple components emerge where we expected only one, we'll face a new type of phenomenon. Not necessarily artificial, but definitely something outside our previous experience. The beauty of science is that nature always has the final word. Atlas is about to provide that reality test in a way few scientific discoveries can. The blackout ends in November, telescopes around the world will reacquire the object, and then we'll know if we're observing exotic chemistry from another stellar system or something that defies current categorization. Regardless of the outcome, it has already expanded our perspective. It has already forced us to question assumptions and confront our own ignorance about the vast cosmos we inhabit. In 3 days, processes that may redefine our understanding of the universe will be occurring behind our star, invisible and undetectable. In 3 weeks, we'll begin to see the results. The Atlas mystery is about to be resolved.